From ContainerDays Hamburg, this video is proudly presented by DAX IT.
Though I won't go into too many technical details in this talk, it's a bit more on the surface, and I was hoping to do a bit more of Q&A and maybe questions afterwards, because the topic is really, or it can get really complicated, and there's no way I could put this on the slides to really explain what we're doing. But yeah, so let's get started. Kubernetes, we all know it, right? And it's a great thing, but there are some things which usually are not included, like the CSI, CNI, and the thing of this talk, the load balancers. So usually these are things that you need to install afterwards, or you need to pick different components, etc. And the Kubernetes world is a world of many cooks, all cooking something in the kitchen. And yeah, there's so many options, you never know what to do or how to do it. And the thing with load balancers is it can get quite complicated, especially as when you run your Kubernetes cluster on-premise or on bare metal or some cloud provider that doesn't have an integrated load balancer solution, or you might not even want to use the solution from the cloud provider for vendor lock-in reasons or other reasons that you might have, right? So enter MetalLB. I'm sure most of you have heard of it already or know what it is, right? It's just a component that you can install in your cluster that provides you with services of type load balancers, or it basically knows what these are, and it will try to provide an IP to these services. Usually it's called a bare metal load balancer or provider of bare metal load balancers. I don't really like the word bare metal load balancer because I think it's a bit misleading. It's actually a non-cloud provider load balancer. It doesn't need to be bare metal. It can also be virtual machines in some cloud or whatever infrastructure or hypervisor that you have, right? The word bare metal is a little bit misleading, and it's doing it a bit of disservice, I think, because you might want to use MetalLB even if you would run in a cloud, as mentioned before, because you want to be independent, you want to be able to move your Kubernetes cluster to some other infrastructure, etc. So MetalLB can make connections or can announce IPs via layer 2 ARP or via BGP. And in the case I will show, we are actually using BGP in my company for the product that we are building for our customers. And I will get to that later. The problem, though, if you have MetalLB in your Kubernetes cluster is you install it there, you configure it there if you're cluster admin, and as I mentioned, we're using BGP peering, but if you do that, it's in that cluster, right? And at our company, we are providing managed Kubernetes service to other customers. So obviously, we can't just install MetalLB in these clusters and configure them to peer with our networking infrastructure, because, well, they will see that, they can mess around with that. So what do you do, right? And this is, this picture actually even more explains it a little bit more. It's a bit complicated at first glance, but the thing we do at Swisscom is, so we have a very large bare metal Kubernetes cluster, where we install KubeVirt, and we have KubeOVN as the CNI on it, etc., etc. And the thing is, so we create namespaces on this KubeVirt cluster, and each namespace is like a tenant for a specific company or an external customer. And in that namespace, we create VMs again, and in those VMs, we create Kubernetes, and we install the product KKP from Kubermatic, if you know it. It's just a tool to manage and provision Kubernetes clusters for users. And obviously, our customers expect to have load balancers, because you can't provide Kubernetes to a customer if you don't have load balancers. It's like, what's this for, right? And with our networking infrastructure, we also have like router pods within each of these namespaces, and these router pods peer with our core network to go to the outside world or to go to the network of the customer, etc. So Now the question is, okay, where do I place MetalLB? I can't put it on the user clusters because we can't expose this to customers. And this is where the KubeLB enters the picture. KubeLB is also a software from Kubermatic, so we also chose to use this because it basically allows like federation or central management of load balancers. So what you do is you install this KubeLB in some kind of a central cluster. For us, it's one per these namespaces that I've shown. And this KubeLB has like a manager component and a CCM component. And the CCM component will be installed into the user cluster, and it communicates with the central manager. And whenever you need to provision a load balancer in a user cluster, so it will see it, and it will actually provision the load balancer. Or maybe it helps if I go to the next picture. Yeah, this is a bit of a high-level view. I stole the picture from the Kubermatic website. But the idea is you have this manager in the central cluster and the CCM in all the user clusters. When the CCM sees a service of type load balancer that a user wants to have, he talks to the manager. The manager actually creates also a service of type load balancer. MetalLB, which is installed in the management cluster, will see this, will provision everything, will set up the IP and the peering, announce the IP and all that stuff, and then the manager will get back to the CCM and tell it, okay, this is the IP I got. So he will also set the IP in the load balancer, which is in the user cluster. And now we're wondering, okay, well, that's great, but how does the traffic get there? So MetalLB is the thing that will attract the traffic on the management cluster, and the KubeLB manager will install an envoy deployment, which is configured to actually forward this traffic to a node port in the user cluster, which was set up by the CCM. So I think the next picture shows this a bit more. Pardon my drawing, I'm not the greatest draw.io artist, but this is basically like the result that will happen. So you see we have our network, we have MetalLB in this tenant management cluster. There's some load balancers created. MetalLB will announce the IPs. And there's actually an envoy deployment there, which routes the traffic to a specific node port that the CCM in the user cluster set up. And the IP then gets written there or put as the external IP to the service in the user cluster. And so from the perspective of a user, all he sees is he creates a service of type load balancer. A few seconds later, it gets an IP assigned, and he starts receiving traffic on this IP without being able to actually see the MetalLB behind the scenes, right? That's the main purpose. So he can't interfere with this MetalLB, he can misconfigure it, etc., etc. The slightly special thing is that this KubeLB CCM that's in the user cluster, because we are using the KKP product, this one is also hidden from him. It's a bit a technical detail on how Kubermatic does it, but he also doesn't see the CCM. But even if he would see the CCM, all he has basically is like a service account into a specific namespace in the tenant management cluster. So he could only mess up his specific CCM and not interfere with the one of other clusters. So even that is separated from each other. And yeah, this way we can provide load balancers to customers without them being able to interfere or mess with our networking infrastructure. And we use MetalLB, right? We chose it because we are using BGP peering to our network, but we could have just as well chosen like Cilium can do it these days or anything else. It doesn't really matter. The point is just that the KubeLB manager creates a service of type load balancer also in this management cluster and then just routes the traffic through to the actual user clusters. Yeah, this is pretty much what it does. The next few slides are just examples of how this looks. It's not so interesting because I guess every one of you has created a load balancer before, but basically you create this in the tenant cluster here. In this case is the user, so the cluster that our customer actually has. He just creates a load balancer with some MetalLB annotations, whatever. They are actually replicated into the management cluster by this KubeLB product, so you can use all the annotations that whatever actual load balancer deployment or product that you're using, you can just replicate them. it will create a load balancer, it will get some IP. Maybe this is a little bit interesting because I was mentioning this Envoy deployment. This is how it looks in the management cluster when a user has created a load balancer. So you see there is a CRD load balancer, which is this KubeLB specific thing, and then it will just create an Envoy deployment, which is the one that will route the traffic through, and it gets a service also. This is the actual load balancer service from MetalLB's perspective that gets the external IP, and it just points to this Envoy deployment, which then points to the node port on the user cluster so that the traffic flows in there. Yeah, the great thing is KubeLB also understands gateway API. So you can create, in the management cluster, you create a gateway class, whatever you want to call it, and it will just do a few things in preparation, right? This is just how it looks. We are using Envoy Gateway, just as an example. And in the tenant cluster, you then can create a gateway, which refers to the gateway class that's in the management cluster. So you just need to inform your users, hey, please use this gateway class name. That's the one we will provide. And then they can create a gateway, an HTTP route in their cluster. That's what they will see in their cluster. So we see the gateway actually got an external IP. This is the one that also MetalLB was facilitating in the management cluster. And if we switch over to the management view, it will also, again, replicate the entire gateway object and HTTP route object into a specific namespace in the management cluster, where it will get the IP and all that kind of stuff. And again, it creates an Envoy deployment which routes the traffic through to the user cluster. Yeah, that's pretty much it. My time is almost over. We have just a few minutes left for Q&A.
Let's go for the first one. How does KubeLB compare to KubeVip? This is a question I would ask.
It's a bit difficult for me to say because I've never actually used KubeVip. As far as I understand it, it's similar to MetalLB in terms of a product. So KubeLB is more about actually just managing any type of load balancers from management cluster to user or tenant clusters. It's just about doing this coordination. So you could, if I understand KubeVip correctly, you could use KubeLB and KubeVip to do the same thing as we do with KubeLB and MetalLB.
How can a customer mess with BGP if MetalLB is running in a user cluster? Oh, there's a lot of ways.
Yeah, so if we would put MetalLB in the user cluster, we would obviously also need to put its configuration there, like the BGP peering configuration, password to our networking infrastructure. And of course, on our networking router, we can filter some prefixes and stuff, but we just don't want them to be able to even see this and maybe spawn up their own BGP process that then peers with our router and starts announcing whatever, I don't know, whatever crazy route. I mean, customer could announce 1.1.1.1 if he thinks this is funny, and we just don't want that, right? We want to have it abstracted so it behaves in the same way as load balancers do in the global public cloud providers, right?
Can a single user cluster become a noisy neighbor to the other user clusters in the setup with KubeLB?
I hope not. We haven't had this case yet. So what I maybe forgot to mention is these Envoy deployments that happen in the management cluster, there is one each per user cluster that's managed. And each user cluster is represented as a namespace in the management cluster where this Envoy is. So in theory, they should not become noisy neighbors, except maybe at some point they might saturate the bandwidth of whatever worker nodes I have in the management cluster. But I hope that's not going to happen, and then we just scale out more worker nodes and hope that our network can cope with it. But let's say normally this shouldn't be the case.
Great. This is the last question that we have on Slido. Do we have one last question on the audience, perhaps? No one? 3, 2, 1? Okay. Thanks a lot for your talk. It was very interesting. A big round of applause, please.
From ContainerDays Hamburg, This video is proudly presented by Dux IT.